Hello students, today we're going to study the numerical based on the nozzle. The first of all we take the numerical steam at 10.5 bar and 0.95 dryness is expanded through a convergent divergent nozzle. The pressure of steam leaving the nozzle is 0.85 bar. Determine find velocity of steam at throat for maximum discharge. Second, the area at exit. Third one, the steam discharge if the throat area is 1.2 centimeter square. Assume the flow is isentropic and there are no friction losses. Take n equal to 1.135. So in this numerical, the steam having a pressure 10.5 bar and having a dryness fraction 0.95 expanded in the convergent divergent nozzle. At the same time, when the steam is leaving the nozzle, the pressure is 0.85 bar. That the in this case what happens, the pressure difference is given and determine the velocity of steam at throat. That is, you have to find the velocity of steam at throat section. You have to find the area at exit from which steam passing. The steam discharge if the throat area is 1.2 centimeter square. How much amount of steam discharges when the throat area is 1.2 centimeter square, and consider the flow is isentropic and there is no friction losses. So in this numerical, first of all, you have to identify the pressure P1 and you have to find out the values from the steam table. P1 is the 10.5 bar, P2 is the 0.85 bar, and the area at throat section 1.2 centimeter square, external dryness fraction is 0.95, and here is the expansion index is given 1.135. So for that purpose, you have to find out the first of all your throat pressure, because this numerical belongs to the throat pressure. Therefore, you have to find out throat pressure. The throat pressure formula is P3 equal to 0.577 into P1. You multiply by P1, pressure P1 will get the 6.06 bar. Then from the steam table, you have to find out the values at 10.5 bar. Go to steam table and you have to take the values HF, SF, HFG, SFG, and all these values. HF equal to 772 kJ per kg, SF equal to 2.159 kJ per kg Kelvin. Okay, and then HFG in this case 2006 kJ per kg, and SFG equal to 4.407 kJ per kg Kelvin. And having a pressure, throat pressure, we are getting 6.09. Again go to the steam table. You have to find out the value. HF is the enthalpy and entropy, HFG, SFG, VF, VG. All these values given this numerical. HF equal to 673.25 kJ per kg, SF equal to 1.9375 kJ per kg Kelvin, and HFG is the 2082 95 kg per kg, and SFG 4.815 kg per kg. VF and specific value 0.01101 meter cube per kg, and VG 0.31556 meter cube per kg. Then go to the another pressure. The pressure 0.85 is in the nozzle section. During the nozzle section, that time you have to again go to steam table, find out the HF value, HFG, SF, SFG, VF, VG. You are getting the all values. Then you have to find out the SF. SF is SF1 plus X1 SFG1. You have to put the value in this case 2.159 plus 0.9 into 4.407 will get a 6.34565 kg per kg Kelvin. You are getting the entropy values. Then you are find out the enthalpy values at point H1. H1 equal to HF1 plus X1 HFG1. You have to put the again values 772 plus 0.95 into 4.407 equal to 6.34565 kg per kg Kelvin. You are getting the enthalpy at point 1. Then in this case, the isentropic expansion between inlet and throat. In this case, the isentropic expansion between the inlet and throat. Therefore, S1 equal to SF. You are getting the value again steam table 6.34564 kg per kg. Then STM in the throat section. You have to get the entropy SFT plus XT x SFGT. Put the value 6.34 565 equal to 1.9375 plus xt into 4.185. You are getting the value 0 xt dash section throat section 0.915. Then you are find out the HFT plus xt HFGT. You are getting the enthalpy value at throat section. You are getting value 2579.15 kilojoule per kg. Then you have to find out the velocity of steam at throat section. VT you are getting 443.96 meter per second. Then you have to find VT equal to XT into VGT 0.915 into 0.31156, you will get 0.287 meter per kg. You are getting the VT. In this case, to determine the mass of steam discharges, how to find the mass of discharges? Again, you have to put the values, put the equations 80 into VT divided by VT 1.2x into 10 minus 4 into 443.96 divided by 0.28874, we get the mass of steam discharge EM equal 0.1843. Then go to the isentropic expansion between the throat and exit. Before we discuss about, then go to find out the isentropic expansion between the inlet and throat section. S1 equal to SF equal to 6.34565 per kg. Then find out the ST, the throat section. ST equal to SFT plus XT into SFGT. You will give put the values, and from these values you will find the XT 0.915. Then again find the enthalpy ST equal to HFT plus XT HFGT. Then we will find the value of throat section, enthalpy section. We are getting 2579.15 kg per kg. Then you are finding out the velocity of steam at throat section, VT equal to 443.96 meter per second. Then VT equal to XT into VGT 0.915 into 0.31156 equal to 0.2887 meter cube per kg. Then you are find out the mass of steam discharges. The at X at 80 into VT divided by VT equal to 1.2 into 10 minus 4x 443.96 divided by 0.28874, we will get the mass M equal to 0.1845 meter cube per kg. Then we discuss about isentropic expansion between the throat and exit. The ST equal to 6.34565 kJ per kg Kelvin. Then put the all values, we are getting the value of X2 equal to 0.83, the Dias fraction. Then find out the V2 values, and the V2 values equal to 0.83 into 1.973 equal to 1.73. Put all these values, you will get the V2 values. Then velocity of steam at exit, V2 equal to under root 2000 in bracket H1 as S2 equal to under root. Put the all values, we are getting the 889 meter per second. That means we are getting the velocity of steam at exit equal to 889 meter per second. This then apply according to the mass balance. The steam flow rate of throat is equal to the flow rate at exit. That means this is the equation to be balanced in this case, and you have to consider the steam flow rate of throat is equal to the flow rate at exit. EMT equal to EM2. The EMT equal to A2 into V2 by V2. Then put the values 0.1845 equal to A2 into 889 upon 1.635. You are getting the A2 values. That is the area of, in the numerical, you are finding out the area at exit. The area at exit, you have to find this equation, and this is the end of the first. Then go to another numerical based on the nozzle again. Dry saturated steam at 2.8 bar is expanded through a conversion nozzle to 1.7 bar. The exit area is 3 cm square. Calculate the exit velocity and mass flow rate for the isentropic expansion. Again, this numerical belongs to the nozzle, convergent nozzle, because nozzle has three types: convergent, divergent, and then convergent divergent nozzle. The dry saturated steam at a 2.8 bar expanded through the convergent nozzle. That means the steam having a pressure expanded in the convergent nozzle to 1.7 bar. They expanded in the convergent nozzle. For first 2.8 bar was the starting pressure, and final pressure 1.7 bar. The exit area is 3 cm square. Exit area is the 3 cm square, and calculate the exit velocity and mass flow rate for the isentropic expansion. That means exit area is given in this case, and you have to find out the exit velocity and mass flow rate for the isentropic expansion. First of all, you have to write the given input. The pressure P1 is given 2.8 bar, P2 is 1.7 bar. Then area, exit area is given A2 equal to 3 cm square. Then finding out this, again use the steam table. By using the steam table, you are putting the value P1 equal to 2.8 bar. For getting the enthalpy H1 2721.5 kJ per kg, then you are getting the S1 entropy S1 equal to 7.014 kJ per kg Kelvin. Then finally specific volume V1 equal to 0.64600 meter cube per kg. Then P2 1.7 bar. Again from the P2 you have to get in the steam table values. From steam table we are getting the value enthalpy, HF, HFG, SF, SFG, VF and VG. HF equal to 483.2 kg per kg, then SFG 2215.6 kg per kg, SF equal to 1.475 kg per kg Kelvin, then SFG, that is entropy 5.706 kg per kg Kelvin. VF specific volume, VF equal to 0.001056 meter per kg, and then VG equal to vapor 1.0309 meter per kg. Then for isentropic flow, you have to consider S1 equal to S2. That means isentropic process, therefore S1 equal to S2, therefore S1 equal to S2 7.014 joule per kg Kelvin. Then again write a formula S2 equal to SF plus X2 HFD2. Put all the values, will get the value of X2. For this values we are getting the dryness fraction X2 equal to 0.97. Then from this value you are getting the find out the value of enthalpy S2. S2 means S2 HF2 plus X2 HFG2. Put the values, then we are getting the values S2. That means 483.2 plus 0.97 in bracket 2215.6 equal to 2634.1552 kg per kg. These are the enthalpy at point 2. Then you have to find the V21 and V22. That V21 extend VG2 that 0.97 into 1.03091 meter cube per kg. Their velocity of steam at exit V2 double, their under root 2000 in bracket H1 minus S2 equal to 418 meter per second. And this is the value to be finding out. Velocity of steam at exit 418 meter per second. Then find out the mass flow rate of at exit M2 equal to capital A2 into V22 divided by V21. We put all the values, you are getting the M2 0.1306 kg per second. And this is the end of the second numerical. Then go to the another numerical which is based on the again nozzle. The third numerical, dry saturated steam at a pressure of 8 bar enters a CD nozzle and leaves it a pressure of 1.5 bar if the steam flow process is isentropic and if the corresponding expanding index is 1.135, find velocity of steam at throat. Again, this numerical belongs to the nozzle section. First of all, in this numerical given, the dry saturated pressure having a pressure 8 bar enter the CD nozzle. Again, convergent divergent nozzle. CD means convergent divergent nozzle, and leaves it the pressure 1.5 bar. And when it leaves the steam having 1.5 bar, then if the steam flows process is isentropic, the flow process is considered as the isentropic process. If the corresponding expanding index is 1.135, find the velocity of steam at throat. In this numerical, again the steam passing through the convergent nozzle having a pressure 8 bar and then leaving the convergent nozzle, that time the pressure is 1.5 bar, and in this case the process is isentropic, expanding index is there. To determine the velocity of steam at throat section, first of all you have to write the pressure P1 equal to 2.8 bar. In this numerical, the P1 pressure is 8 bar, P2 is 1.5 bar, and an expanding index is given. Then we know that the throat pressure is given by the formula Pt equal to 0.577 into P1. You have to multiply it 0.577 into 8 equal to 4.62 bar. You are getting the throat pressure, and then you have to find the properties of steam at different section, different pressure lines. Properties of steam at steam table at point 8.58 bar. You are getting enthalpy H1, entropy S1, and a specific volume is given. The H1 equal to 27610.1 kg per kg, S1 entropy 6.6628 kg per kg Kelvin, and specific volume V1 equal to 0.2404. Then you have to determine the properties of steam at 4.62 bar, that is the throat pressure. Then you have to determine H1, SFG, S1, SFG, VF and VG. The H1 equal to 626.7 kg per kg, HFG equal to 2117.2 kg per kg, S1 equal to 18.29 kg per kg Kelvin, SFG 5.018 kg per kg Kelvin. Then VF specific volume 0.001090 meter per kg, and VG equal to 0.40526 meter per kg. Then you have to find the values from the stream table. Again, go to the stream table. Again, at 1.5 bar, you have to find out the value HF1, SFG, S1, and SFG, VF and ST. Then H1 equal to 467.11 kg per kg, HFG equal to 2226.5 kg per kg, S1 equal to 1.4336 kg per kg Kelvin, SFG equal to 5.7897 kg per kg Kelvin. Then find the VF 0.001053 meter per kg and ST, that the stored section enthalpy 2666.18. Then VT, again you have to find out the VT equal to XT into VGT, multiply that 0.963 into 0.40 equal to 0.39 meter per kg. So you are getting this. And then find out the, finally you have to determine velocity of stream at throat. See the formula VT equal to under root 2000 in bracket HM minus ST. You have to put the values in this equation. You're getting the velocity of stream at throat 477.749 meter per second, and this is the velocity of stream at throat. That means this numerical belongs to, again, that means the all we have today we have taken the all the three numerical, in which what happens, the stream is passing through the conveyor nozzle, having a pressure, having a transfaction, and enter and expanded into the steam, in the enter into the nozzle section, and when it leaves the nozzle, that time the pressure is different, and you have to consider the process is isentropic and determine the different values, that the velocity of stream at throat, and you have to find out the mass flow rate, you have to find out the exit velocity, or again you have to find out the velocity of stream at throat section, and this is the throat area. And this today we'll discuss the numerical based on the nozzle section. This is the end of the today's session.